In this video, I will explain how you solve this question, which involves integration. So we are given some conditions for the function f, where f of 0 is equal to -4 and f of 1 is equal to 0. But we do not know directly what f is. Instead, we know what the double derivative is. So we know that f double dash x is 15 root x plus 1 over x plus 1 whole square, where x is greater than or equal to 0. And we're asked to find f of x. So as a quick recap of what integration is. So we know that when you derive something, you get, which is essentially finding the tangent function of a certain function. So for function f of x, the tangent function, which is the function get after differentiating it, is f dash x. Now, if you do that again, if you apply the same differentiation, you get f double dash x. Now, integration is essentially going backwards in this cycle. So when you integrate f double dash x, you get f of x, so integral. And then when you do that again, you get f dash x, so again, another integral. Now, if you've done derivation, you know that if you have a constant, let's call it plus c in f of x, and when you derive f of x to make f dash x, that constant becomes 0. It essentially disappears. This is because when you have a constant of coefficient c or of value c, you have an x, you have the x to the power of 0. And because x to the power of 0 is essentially just 1, you get c times 1, which is c. Now, because this is x to the power of 0, when you derive this, you're essentially doing 0 times c times x, 0 minus 1, which is 0 times c times x to the power of -1. However, because you have the 0 over here, everything here becomes 0, because no matter what this value is, we know that if you multiply anything with 0, it is 0. Therefore, this, when you derive a constant or a coefficient which has the x to the power of 0, you just get 0 after deriving. Now, if you're doing this twice, we know that there have been 2 times where this situation has occurred. Now, when you're going backwards, that means we're going to find these 2 missing coefficients. So one, when you derived f of x to f dash x, so there was one coefficient which became 0, and then again, same from f dash x to f double dash x. So what that means is we're essentially going to find 2 unknown coefficients of x. Actually, one is a coefficient and one is a constant when you're doing this double integral back to f dash x, which is where these conditions come into use. So let's actually start the process and see how that ends up. So I'm going to remove this first. And let's start. So first, we're going to do the double integral to find f dash x. So f double dash x is equal to 15 root x plus 1 over x plus 1 whole square. Let's find the integral of that. So f of x, f dash x is the integral of 15 x to the power of half to make things easier, plus x plus 1 to the power of -2. This just makes it easier for us to derive dx, obviously, because with respect to x. When you do that, you get 10 times x to the power of 3 over 2 minus 1 over x plus 1. And because over here we do not have any domain for this integral, we do plus c. Now, to get this, essentially what we're doing is we're doing differentiation backwards. So we know for the fact that whatever came to this, so if you have a certain term, let's say e of x to the power of n, so whatever led from this to its derivative, which in this case would be n e to the power of x n minus 1. So what integration is, as I mentioned before, is just going backwards. And this is what we're doing here. We're trying to find what was derived to find this. And in this case, we get 10x to the power of 3 over 2. Once again, minus 1 over x plus 1 is the integral of this term over here. Dx just says with respect to x, and this plus c is here because when you derive, you lose any constants, as I showed before. So now you have this, which is our f of x, f dash x, sorry. So now to find f of x, we repeat this process. So f of x will be equal to the integral of f dash x with respect to x, which is the integral of 10x to the power of 3 over 2 minus x plus 1 to the power of negative 1 plus c with respect to x. Now, when you integrate this, you get 4x to the power of 5 over 2 minus, now x plus 1 to the power of negative 1 is an interesting situation, because if you follow the traditional logic of integrating, you would have something divided by 0. Now this won't make sense because minus 1 plus 1 would be 0. So when you write it out, you would get something like x plus 1 to the power of 0, which is fine. However, we must remember when integrating, we also, whatever the power is here, we divide everything by that power, which will become 0, which is not defined. However, we can make use of ln, which is the log with the natural base. So base of e, x plus 1, which will be a term here, plus, now, because we don't know what the constant is, we do know that it did have an x before. Essentially, this would become cx. Now, because we are integrating once again, we have another constant, so that we can write as d. So this here is our f of x value. However, when they ask us to find f of x, they expect us to find it with no other variables apart from x. So we need to find c and we need to find d. This is where the two conditions come into play. So f of 0 is equal to minus 4, f of 1 is equal to 0. So let's try that out. So we have f of 0 is equal to minus 4, and we have, let me just write that again. And f of 1 is equal to 0. So let's substitute 0 into this. So we have f times 0 to the power of 3 over 2 minus ln 0 plus 1 plus c times 0 plus d is equal to minus 4. So 0 to the power of 3 over 2 is just 0. 4 times 0 will be 0. So that's 0 minus ln of 0 plus 1, which is ln of 1, which is again 0, plus c times 0, which is again 0, plus d is equal to minus 4. Therefore, d is equal to minus 4. So that is our first variable solved. So we know the value of d. Now we can repeat the same process. Because we know d, we can sub in the value of d now. So we have f of 1 is 0. So 4 times 1 to the power of 3 over 2 minus ln 1 plus 1 plus c times 1 plus d, which we know is minus 4. So minus 4 is equal to 0. Solving this, we know that 1 to the power of anything is just 1. So that's 4 times 1, which is 4, minus ln 1 plus 1 is just ln 2. We can write it as that, ln 2, plus c times 1 is just c, minus 4 is equal to 0. Now we can remove the 4 and minus 4 over here. Then we are left with minus ln 2 plus c is equal to 0. So therefore, c is equal to ln 2. Now we can write out the full expression that we know. Therefore, let me write this in red. So therefore, f of x is equal to 4 times x to the power of 5 over 2 minus ln x plus 1 plus cx. So because c is ln 2 and cx will then be x ln 2 minus or plus our d value, which is minus 4. Therefore, it will become minus 4. So this is our answer. However, you can also write it in this form where we have 4 And because this means the square root of x to the power of 5. So this is x to the power of 5 square root minus ln x plus 1 plus x ln 2 minus 4. So either of these two would be acceptable results to our answer over here. Let me just highlight this. Again, I personally prefer to write it in this manner. It's just neater and it's easier to read. However, you can write both ways, it'll be correct. And that is the answer. And that is how you find f of x when you're given the condition, two conditions for f double dash x, as well as the equation for f double dash x.